Hello, welcome along to the Fun Kids Science Weekly podcast. My name's Dan. Thank you for finding us. Thank you for listening. This is officially the greatest podcast in the history of the universe. I've got the award and everything. And there are two pretty important people at this time of the year. Father Christmas, obviously, with a big sack full of presents. And I know it's not very modest of me to say so, but the other is me, with a podcast full of science stuff for you. Thanks very much. This week, we'll take a look at one of the most remote, feared tribes in the world. Also, you can hear what is happening with the big iceberg that's floating across the sea. And I've got some of your questions to answer, as always. This week, they're about dreams and about deadly poisonous things in the ocean. We'll check in with those in just a sec. First, let's catch up with one of the smartest schools outside of the solar system. This is Deep Space High.
Deep Space High, space for all.
Jump into your wormhole and travel to Deep Space High, the school in space. But hurry, because lessons are about to begin.
Morning, class. Right, who can remind us what we've learnt about careers in space? Sam?
That it's not all about rocket scientists, and that space is for everyone?
Correct. Although rocket scientists are important if you want to get off the ground. So today, Trix, why don't you get us started by telling us what your favourite subject is, and we'll see how you might turn your skills to the stars.
Well, my favourite subject is English. I especially love writing stories, but space is more about facts, I guess, not fiction.
English is integral to space exploration, and fiction has its place too. We need great science communicators, people who can describe and report on missions and discoveries in a way that makes other people keen to know more, especially young people who might want to work in space themselves.
Oh, that's like that magazine we get, Andromeda Express. It's full of the latest cool mission news and spacecraft. I guess someone had to write the articles in it.
That's right, but there's an even more exciting way writers are part of space exploration. Anyone a fan of science fiction books or movies?
Me, sir. You mean films like Star Trek with Captain Kirk and Spock on the Starship Enterprise? Or Ready Player One, that film where everyone lives in virtual reality?
Yep. Science fiction is where the writer imagines what life might be like in the future, sometimes on Earth, sometimes on other planets.
But it's only imagining, isn't it? How does that help?
Let's see. Computer Sim, Paramount Studios, USA. The original Star Trek TV series in the 1960s showed characters using small devices to communicate with each other, which led to the invention of the first mobile phone, because the inventor, Martin Cooper, was a fan of the show and was inspired by the idea. Next, Computer Sim, Blade Runner, a movie set in a future America where robots live alongside humans.
We're in a self-driving car.
That's right. This film came out in 1982, many years before such a thing was invented for real life. It existed in the writer's imagination all those years before. One more sim, hold on to your hats.
Whoa! We're rushing towards Earth at 100 miles an hour.
Actually, we're inside Google Earth, an app that lets you zoom in on anywhere on Earth. It's said the designers got the idea from a science fiction book called Snow Crash. Oops, getting a bit too close now. End sim.
For you.
People who are expert communicators can tell the stories of what we're doing in space and what we might do in the future. Inspiring real missions and technology. It's more powerful than you think. There's even a saying, the pen is mightier than the sword.
Bit difficult to do your homework with a sword, though.
Science fiction has even changed the language we use. Did you know that the words robotics, cyberspace, zero gravity, gas giant, avatar, and computer virus were all coined by science fiction writers?
No way!
So, Sam, you were struggling to think about things you like to do. Maybe you'd like to write an exciting science fiction story.
I think I'd prefer to read them. Or actually, just watch a movie.
There must be something you like to do, other than as little as possible. Never mind, Sam. Our search will continue, learning how whatever your interests, space is a place for all. All right, class dismissed. Beam me up, Scotty.
Deep Space High, space for all. With support from the UK Space Agency. Find out more at funkidslive.com/space.
Let's get to your questions then. Thank you so much for sending your questions, leaving them as a review over on Apple Podcasts. This is Jamie, who is from Northern Ireland, who says, well, this isn't just the best podcast in the universe, but also the multiverse too. Jamie, thank you so much for those kind words. I've yet to be invited to any multiverse podcast awards. I don't know if they exist. Jamie, though, if you hear about any ceremony that's happening out there in the multiverse, if they're looking for entries for the greatest podcast, please do send it my way. Anyway, you ask a question, you want to know why we dream. It's an interesting one, this, Jamie. Scientists know how we dream, but they're not exactly sure why. Now, dreaming normally happens during what's called REM sleep, rapid eye movement sleep, where neurons in your brain are firing very, very, very quickly. Your eyes are fluttering all over the place. We think it's because they're having a look at what's happening in your dreams. Your eyes are trying to find them, trying to see them. Now, some experts think we dream to understand the world around us in a safe way, because we can act things out in our mind that we can't ordinarily do in regular day-to-day life. And maybe it's to figure out something that's happened way in the past that you've hidden away, that you're trying to kind of come to terms with. Now, during dreaming, the logical part of the brain is slowed down, which is why they can be a little bit random, a little bit all over the place. Now, during REM sleep, even though your brain is going at like 1,000 miles an hour, the voluntary muscles of your body, which are the arms, the legs, the fingers, anything you can control, they're all paralysed. Which, if you think about it, is a pretty good job, because otherwise you would try and go and act out things that are happening in your dream, and you don't want to try and fly without wings. And that also points to why sleepwalkers usually aren't dreaming when they're sleepwalking. That's a common myth that people think. So yeah, kind of figured it out, Jamie. It's a really tough one though, but thanks for the question. Also, this is from Lucy, who is 9 years old, who says that this podcast makes her go to sleep. I'm not sure if that's a good thing or a bad thing. But Lucy, thank you so much. You want to know what's the most dangerous animal in the ocean? It's hard to define, isn't it, the most dangerous? But I can take you through the top 10. And we have covered most of these in old episodes of the show as Dangerous Dan's, Lucy. So go and listen to those if you can. Here are 10 of them. The lionfish, painful, venomous. It's a spiky fish from the Caribbean. You've also got sea snakes in the sea. You've got a cone snail, which is strange, but a drop of their venom can be deadly for up to 20 people. You've got stingrays, you've got the great barracuda, you've got the flower urchin, which is covered in venomous spikes, which makes you paralysed, then you die. You've got stonefish. Now, if you see one, don't get confused and think this is a stone. It's not. It's a very well camouflaged fish. They can leap out, they can attack. You've also got the deadly blue-ringed octopus, the saltwater crocodile, and probably the most dangerous creature in the ocean, Lucy, is the box jellyfish. Pale blue, it's almost invisible. They are amazingly quick. They've got enough venom to cause real damage to up to 60 people. In a second, this week's Dangerous Dan will have a look at one of the most remote tribes on the planet. Thank you for the questions. If you've got something sciencey that you want answered on the show, you need to leave it for me as a review on Apple Podcasts. It's the Fun Kids Science Weekly. It's one of my favourite times of the year when we talk about the Royal Institution Christmas lectures. And this year, we've got Dr. Helen Czerski. She's doing a brilliant one. And she's a bubble scientist, which I need to know more about. And she joins us on the show. Hello, Helen.
Hello.
Thank you so much for joining us. I'm going to start with the most obvious question. What's a bubble scientist?
Well, the first thing to know is it is a real job. And yes. So I'm a physicist, so I study the sort of forces and energy that make things work in the world. And bubbles are really interesting and really important, but they're sort of they're hidden heroes of the everyday world because we never really look at them. So there's bubbles in the kettle and in the bath and, out on the ocean. And you sort of see bubbles around once you start looking for them. But actually, the important thing to know about bubbles is they're always doing something. They're always moving something around. Or getting in the way, or generally getting involved. And so as a bubble physicist, my job is to study the bubbles and what they're up to. And they do lots of things. They tell us how big they are quite often. So if you pour out a glass of water and you hear it going, all of those little noises are bubbles that are making a ping at the moment they formed. And they're telling you how big they are. So just like a big bell will make a deep note, a big bubble will make a big note, and a little bubble will make a little note. And one of the cool consequences of that, which isn't actually my job, but it's quite interesting, is that when you listen to your tummy gurgles, those are bubbles and they're telling you how big they are by the note of the gurgle.
Right. So about 1 million questions immediately ping off in my brain for that. let's talk about the tummy thing very, very quickly. Why are there bubbles in our tummy?
Well, we have, our gut is busy doing lots of things. It's processing all the food that we put in there, and there is gas in there as well. So sometimes that gas has to move around, and it has to move along the gut, and then you get bubbles of gas that all gather in one place, and then they move along together.
And I know that you said
swallow gas as well. When we eat, we swallow gas, and so there's some of that in there as well.
We do gulp a lot of it. I know you said that this type of bubbles isn't exactly your speciality, but you seem to know more than I do about these bubbles. And is it that we seem to make more bubbles when we're hungry, because when our tummy rumbles and stuff? Is there a connection there?
So anecdotally, I would say it's when you're hungry, but I have never studied this. I've never, it'd be quite easy to do. You just have to put a microphone next to someone's tummy and ask them every 5 minutes how hungry they felt. And you could actually do this study, but I have to say I haven't done it. Perhaps some of your listeners would like to do that experiment and tell us what they find.
That's a fantastic experiment, I think, for 2021. And you said that bubbles, they're telling us stuff, and that they're showing us things. It's always got a plan in mind. Quite often the bubbles are getting in the way. That sounds like there's conscious thought there. But these bubbles are quite random, and they just form, and they're kind of doing what is the purpose of a bubble? What's it trying to do when it exists?
Well, the bubbles are just there, like you say. They're not thinking about this. But a bubble is a very interesting thing. So I don't study soap bubbles. What I study are underwater bubbles. So those are pockets of gas underwater, and they're completely surrounded by water. And the thing is that a bubble is a place where a liquid and a gas are trying not to mix. So the gas is all inside the bubble, and the liquid is all outside the bubble, and the bubble itself exists to keep them separate. But the thing is that when you have a bubbly liquid, then what you have is, it's not quite a liquid and it's not quite a gas. It's got some properties of both. So, for example, bubbles are really good at transporting stuff. So the place where I do study bubbles is in the ocean. And so when a wave out, far out on the ocean where you get really high wind, you get big, big waves, eventually some of those waves will break and they trap part of the atmosphere underneath the wave, and then it gets pushed down into the ocean and it breaks up into lots of tiny bubbles. And so those bubbles are little packets of the atmosphere that are trapped then inside the ocean. But some of them aren't trapped very long. Some of them come straight back to the surface, and that forms the white horses of the sea, the foam patches that we can see. But some of them carry that gas down into the ocean, and the ocean can take them up. So it's like breathing for the ocean. And so that's an example of the bubbles doing something. They're moving a gas from the ocean into the atmosphere. And actually they also send stuff back the other way. So if you drink a fizzy drink and you hold it under your nose, you'll feel it spitting tiny particles up your nose. You can feel the fizz in your nose, right? And that's because when the bubbles burst at the surface, they spit a little particle upwards, and the bubbles in the ocean are doing that as well, and that is delivering stuff from the ocean into the atmosphere. So the bubbles in the ocean, they're not thinking about it, but they're acting as vehicles that are taking gas one way and sending particles the other way.
One of my favorite things to see when I'm in the sea, when I'm in a pool, maybe when I'm in a bath, is when you get two separate pockets of bubbles, and then they slowly, and then they join together, and it makes a much bigger pocket of a bubble. I love looking at that. Is there a rhyme? Is there a reason? Is there a law for what's happening here? Why different bubbles are forming? I'm trying to figure out how to ask this question. Is there what's the science behind different bubble sizes when they join together, and how much gas can make a bubble, if that makes any sense?
Yeah, so bubbles of different sizes are different shapes. So the very, very little ones are almost always spherical, because they're very small, their surface sort of sucks them in, and they're almost spherical. But as you get bigger, you see really big bubbles, they become sort of umbrella shaped, right? You have this curved dome over the top, and it kind of sheds little bubbles from around the edges. So bubble, and the first thing, the reason they join together really is that the big bubbles rise faster than the little bubbles. So the little bubbles go, if you can do this, if you have a fish tank and your fish don't mind, if you lift up a little cup of water from the fish tank and then sort of drop it into the tank, you'll see that the bubbles go down and the big ones rise really quickly and the little ones, they're following behind. They're going really slowly. So if a big one going quickly catches up with a small one going slowly, then they bump into each other, and that's when they join together. And actually, the moment they join together, they make a sound. And I measured that sound. So I've actually written a scientific paper on the sounds that two bubbles make when they join together.
How long was that paper?
How long was it? I don't know. It was quite a short one, maybe 6 pages. It's not very long.
But still, I love the fact that you've got 6 pages out of the sound two bubbles make when they join together. That's beautiful.
Well, it's really important actually, because it means it's not just the sound itself. It's that the shape of that sound tells you something. So when it's loud and when it's quiet tells you something about the joining process. And so I could actually do some physics on how the bubbles join together by studying that sound. So the sound gives away a lot of information. So bubbles, they don't always join together. So one of the things that salt water does that fresh water doesn't is that bubbles are slightly more likely to bounce off each other in the ocean. So in freshwater, if two bubbles meet, they just join together, they form an even bigger bubble and they carry on. But in the ocean, where it's salty, what happens is that if they're not moving very quickly, if one doesn't really smash into the other one, they'll bounce off each other and they'll carry on separately. And this is why. So sometimes if you're near a big lake, you'll see breaking waves on the lake, but you don't see the white foam patches. So you can see a wave breaking, but then there's no foam. It doesn't last very long. Whereas on the ocean, if you see the same wave breaking, you get patches of foam. And the reason is that in the freshwater, the bubbles all join together really quickly, and then they all rise in one big bubble, and then there's no foam. Whereas in the ocean, they stay like lots of separate little bubbles. So you've got lots and lots of little bubbles that haven't joined together, and then they all rise to the surface and sit at the surface, and then they last for a while. And so you can actually tell whether water is salty or fresh just by watching waves break on it.
Now, one of the things I've found really fantastic about doing this show and learning so much that's different about science is that there's so much that's vital about the world that we normal people don't really give credit for. The importance of the rainforest, how they are the lungs of the earth, the importance of bees. And you're talking earlier about bubbles rising to the surface, transporting this gas up. How important are bubbles to the way that the world works in maybe a way that us regular mortal humans don't realise?
Well, perhaps let's stick with the ocean, because if you get me going on bubbles in general, I'll talk for about a week. So there are 3 types, I guess, of bubble in the ocean. I mean, there's a few more, but let's stick with 3. Dolphins make them. Dolphins actually make them as toys. That's not one of the 3. But anyway, so there are the waves. There are the bubbles from breaking waves. They come from the top and go down and go up again. There are bubbles from methane seeps. So there are places where the bottom of the ocean is kind of leaky, and there are trapped reservoirs of methane gas underneath, and it can leak through the surface, and so that you get bubbles that come from the bottom all the way up to the top. And then there are also bubbles in and around sea ice, and we don't know very much about these. I went to the North Pole to study them 2 years ago, and there's lots of bubbles around the sea ice. We don't know exactly what they're doing there. They're very, very small. And so they're a bit of a mystery. But anyway, so with the other bubbles, they do, when it comes to like things that are important for the world, they are helping the ocean breathe by taking gas in and out. And so the methane bubbles, for example, if you have a place on the ocean seafloor which is leaking methane, if that methane gets all the way up to the surface, then you have methane in the atmosphere. And that's a really not a good thing, because methane is a greenhouse gas. It will help warm the planet. So the methane is natural, but if it escapes, then it can cause problems in the atmosphere. And at the moment, it seems that in most places, the bubbles released at the ocean bottom are rising up, but they're not getting all the way to the surface because they dissolve out before they get there. But in some places, I think we're starting to see there are some places where the bubbles do get to the surface and they do release extra methane into the atmosphere. And that gets more likely as the world gets warmer. And so we've got to keep an eye on those bubbles. We can't really stop them, but they're sort of showing us that process of extra methane getting into the atmosphere. This is all quite complicated. There's all these the problem with bubbles is they do all these different things in all these different places, and it's quite hard to keep track.
Well, let me follow up on that. Because I would imagine to someone who isn't as curious as you and people listening to this podcast might kind of think, oh, a bubble scientist. Bubbles are in the sea, they go upwards, surely that's probably about it. You have dedicated a lot of your life to figuring out stuff about bubbles. What is there left to find out? Why are we still researching bubbles and their place in the world?
So one good example is medicine, before I come back to the ocean. So, for example, very tiny bubbles, they don't just act as vehicles for what's on the inside of the bubble. They can carry a coating on the outside, and that coating can be the really valuable bit. So there are people, colleagues of mine, who are making really, really tiny bubbles, too small to see, but they are coated in a medicine of some sort. But because they're quite small, they last quite a long time. So you can inject them into a person and they go through, and they're really small. They're about the size of a red blood cell. So they just kind of go everywhere through your blood. But the thing is that because they're a bubble, you can pop them, and you can pop them using ultrasound. So what a doctor can do is they can put bubbles into you, and the bubbles kind of go everywhere. But then what they can do is direct ultrasound at one place and make those bubbles pop, and that releases medicine in that one place. So there are studies like that where you could actually direct medicine to a very specific point in the body and just release it in that place. And that's still quite experimental, but people are doing that sort of thing. And then bubbles, you know, the bubbles that help the ocean breathe, they're really important, because we need to know how much the ocean is breathing, because climate change is affecting that breathing process, right? It's affecting where the oxygen and carbon dioxide go. And what we want to know is whether the ocean is going to continue to breathe in the same way that it does now. Because as the world gets warmer, maybe it'll breathe differently. And if so, we have to kind of take account of that, right? Maybe it'll change the way other things happen. So we need to pay attention to that. And then there's all the fun aspects of bubbles. So, for example, bubbles make penguins go faster. There is this thing that penguins do where they fluff up their feathers when they're on land. Penguins spend a lot of time preening because their feathers are kind of like their wetsuit, right? You know, it protects them. So they fluff up their feathers and they store bubbles underneath their feathers. They store air, and then they go down, they go swimming, and they swim around and go fishing. And then the critical period comes when the penguin wants to come back to the surface, because up near the surface there are things like leopard seals that want to eat penguins for lunch. So what the penguins do is, on their way up, as they're swimming up to the surface, they want to go as fast as possible, to go fast past all the leopard seals. So they unruffle their feathers and they release all the bubbles, and it kind of gives them a coating of bubbles. And you can see it on video. They're kind of coated in this layer of bubbles, and it reduces drag. It makes them slip through the water. So the estimation is that a penguin that is making bubbles can go 50% faster than the penguin that isn't. And that's quite cool for the penguins. But then big companies like Mitsubishi are trying to do the same thing for ships, because ships use massive amounts of fuel. And if we can reduce that by even a little bit, globally, that's a lot of fuel. Mm-hmm. So they are working on making bubble coatings for ships, like the bubble coatings for penguins, that could make the ships much more efficient and use less fuel. So, the bubbles really are everywhere.
That's the wonder of all things sciencey, isn't it? It's seeing something in the wild and then using that to be more efficient. Now, I started off talking about how I love this time of the year with the Royal Institution's Christmas lectures, because it's a brilliant chance to hear from experts like yourself about stuff we might not normally think about. Now, and I think sometimes listeners to this show, you might think the word lecture is quite inaccessible, but the Royal Institution Christmas lectures are brilliant at making these huge concepts really interesting to figure out. This year, the theme is It's Planet Earth, a user's guide, isn't it? Helen, can you tell us a bit more?
Well, the first thing is there are 3 lecturers. There's me and Chris Jackson and Tara Shine. And so each of us are going to share our own perspective on the same thing, which is planet Earth. And Chris is a geologist. I'm an ocean physicist. And Tara looks at climate change and the atmosphere. And so each of us are going to talk about those 3 areas. But really, because we're all talking about the same thing, we're going to weave those concepts together. So fundamentally, the problem that is facing all of us, each individual, is that we wake up in the morning, go, okay, I'm human, I'm on planet Earth. How do I do this? How do I live as a human on planet Earth? And there are lots of questions about that, right? We know that some things humans do are not very good for the planet. We know that we can make other things, we can change the way we do things to make things better. And we have lots of decisions to make about how to be a human. And so between the 3 of us in the lectures this year, what we want to do is to lay out the map if you like, for, whatever decision you make. This is the information you need about how to make that decision. And so we're going to talk about, how the Earth works, how this machine called the Earth works, and how it has worked through history. And we're going to talk about, the importance of the ocean in that, and how ocean keeps our planet nice and stable and makes Earth habitable. And we're going to talk about what humans are doing to the planet, and what the impacts of some of the things that we do. And all of that is information about, that's kind of drawing the map. That's like, well, this is how it is. This is how it works. And really the aim of this is to show that it's not enough to have the science. The question is what you do with that knowledge. And so the step on is that we're going to tell you lots of science and show you how this wonderful, amazing machine called a planet works. But we also want to show you the things that you can do, like, how should you think about being a human? What should you think, what questions should you ask before buying something or going somewhere or any of those things? And so we want to really give you the framework. We can't tell you all the questions to ask, but we can give you a really good map so you can decide where you want to go.
Oh, I love it. Amazing. It's the Royal Institution's Christmas lectures this year. Dr. Helen Czerski, thank you so much for coming on the show.
You're very welcome. Thank you for having me.
For today's Dangerous Dan, we're taking a look at one of the most isolated tribes in the world. The Sentinelese people live on the island of North Sentinel. And that's almost all we know. The island is near India. The tribe has been living alone, untouched by the outside world for a very long time. Some experts think up to 60,000 years, all on their own. And they attack anyone that tries to get near them. So we can't get close enough to find out more about what their life, what their culture is like, because if you try to enter the island, they might not let you come back. You might not be in a condition to come back. There's currently thought to be around 150 Sentinelese people in the tribe. They're thought to be a Stone Age tribe who hunt and gather their own food. They wear body decoration, tattoos, they make canoes as well. The problem is, because they've been isolated for so long, their desire to stay alone is actually more for their own safety, because they won't have built up any immunity to common illnesses. Little bugs, viruses, the common cold that we might get and you might be able to shake off quite easily, they could prove much more deadly to the people on the island of North Sentinel. It's time to have a look at what's happening inside your body with one of our favourite experts on the show. This is Professor Hallux.
Hallux's Physiology Fix-Up.
Now, what on earth has made that nasty whiff? It smells worse in here than it did after the Renegade Science Egg Night.
Just a little sulphur. Nothing to get worked up about, Nanobot. This is my combustible compostulator. It breaks down foods into lots of lovely nutrients.
And produces some appalling aromas. Never mind compostulator. I'll see you later. If you don't get rid of that stench. It's overpowering.
Smells are a very interesting part of the system I'm trying to improve.
Which is?
The digestive system. The digestive system is a group of organs working together to convert food into energy and basic nutrients to feed the entire body.
And you think that smelly old compost heap can do a better job?
You mean combustible compostulator? Of course it can. I mean, how hard can it be?
Very hard. Organs and systems in our bodies have a number of jobs to do, and they're able to do all these jobs because of the way they are constructed and the way they work with other parts of the body.
All right, I know. So let's put it to the test.
Loading physiology file.
Digestive system. Job 1. The glands of the digestive system make special proteins called enzymes, whose job it is to break down food into smaller pieces or building blocks.
Physiology fail.
Your invention doesn't have any enzymes, just a lot of smells.
Good point. Let's see if it passes the next test.
Digestive system. Job 2. The stomach holds the food and with the help of bile from the liver breaks down fats so that nutrients are released.
Well, my combustible compostulator does hold the food.
But there's no bile to break down the fats.
Physiology fail.
Better luck with the next one.
Digestive system, job 3. Food is absorbed by the small intestine and water by the large intestine, and the waste that is left is expelled from the body.
Well, my invention is brilliant at expelling waste. But as for the rest...
Physiology fail.
What a shame. Well, it's not that the systems and organs in our body can't be improved, but whatever they look like, they need to be able to carry out their important jobs and work with other parts of the body in the right way.
That's right. And the clever thing about physiology is that if you know what job something should do, then it makes it easier to fix things when they go wrong.
Here's an example. There's a rather nasty illness called IBS, which affects the digestive system. It can cause people to have a lot of pain after they eat. But scientists understand the physiology of the digestive system. They're able to see that people with this condition aren't able to absorb all the nutrients from their food. This leads to diarrhea because more food is expelled than should be.
And if you know what's gone wrong, then you're on the right track to make it better. Talking of which, how about a new and improved type of skin?
Here we go again.
Hallux's Physiology Fix-Up, with support from the Physiological Society. Find out more at funkidslive.com/Hallux.
Let's get this week's Science in the News. The RAF from the UK, the Royal Air Force, have released a video from its low flight over the world's biggest iceberg. The iceberg is called A68A. Come up with a catchier name, please. A68A. Anyway, it's 4,200 square kilometres big, and it's crumbling as well. It's about as big as an entire English county. And it's been drifting in the ocean after breaking away from Antarctica in 2017. It's currently 150 kilometres off the coast of South Georgia. Also, another key milestone has been reached in preparation for the joint European and Russian mission to Mars in 2022. The Rosalind Franklin rover, which will search for life on the Red Planet, it's been put on the platform that will land it on Mars. It's the first time these two things have been joined together. And finally, in the UK, 2 national parks have been made dark sky reserves. The Yorkshire Dales and the North York Moors are global leaders in dark sky conservation. They have little light pollution, they have some of the darkest skies in the country, which means you can see thousands of stars, meteors, and even the Northern Lights. And that is it for this week's Fun Kids Science Weekly. If you've got something sciencey, if you want to congratulate us for winning the best podcast in the universe, or if you want to let us know how we could maybe win the best podcast in the multiverse, let me know. Leave it as a review over on Apple Podcasts. I check all the time. I'll make sure I'll see yours and I'll say hello. So leave your name, pop 5 stars in there as well if you can. While you're on Apple Podcasts, it's one of the best places that you can hear all of our podcasts. We've got loads about all sorts of subjects on there. They're also on the free Fun Kids app and at funkidslive.com. And Fun Kids, we're a children's radio station from the UK. You can listen to us all over the country on your DAB digital radio, on that free Fun Kids app, and at funkidslive.com.